Okay, so let's go back through review. Let's just do the notes. We'll do some examples to wake up our brains here, and then we'll call it good for the day. Okay, so mutually exclusive events. So these are events. So you've got event A and event B, and there is no overlap. Okay. So A and B is 0 because there's no overlap. So all of these questions will have the word or in them. Okay, so back to set theory, or means one or the other or both. Or means add. You learned that from perms and coms. So we're just going to take the probability of A and add it to the probability of B. And that's it. Or means add. Union. Yeah. I just remember or is union, and union is a U, and then intersection's got to be the other one, right? Because you got a 1 and 2 shot. Some kids go intersection, like kind of you go your hand and you bring things together, like intersect, right? So you that, whereas union is the U. Whatever works in your brain. So not mutually exclusive. So these are events that do have overlap. So you've got event A, event B, and they do have overlap. Now, the way we do this then, just like with Venns, right? You always start in the middle and work your way out. So what we have to do is or is union. So the question will say or. So you start out the same way. You add up your two probabilities, just like you did on non-mutually exclusive. Sorry, just like you did on mutually exclusive. You add them up. But then you have to subtract off the overlap. So that's the A and B, or in other words, the intersect. So those two formulas are given on your formula sheet. I will say this, what you're going to, and you've got two choices to do all these questions. You can do them all with Venn diagrams, or you could do them all with formulas. It's entirely up to you. I will say this, usually when there's no overlap, I just do it using the formula. I just add up each of the two probabilities. If there is overlap, I will usually do it using the Venn diagram. That's just my, because I always forget to subtract. Like I always forget to do that piece in the formula. So, but I'll show you both ways and let you decide how you want to do it. Okay. On the diploma, if this was a long answer question, they're not going to care. Just remember from set theory, if you're going to use Venn diagram, remember all the work goes on a separate picture. Or if you do put all the work on here, you got to redraw out a clean picture at the end. Okay. Okay. Of course, it's all shifted up too high. Why wouldn't it be? Okay. So I think most of these examples today are actually kind of focusing on the Venn diagram idea. Try that. Oh my. Trying to get my head and my tongue to agree. These questions can all be done either way, but sometimes they give you the Venn diagram. So if they're giving it to you as a Venn, just keep going with the Venn. Okay. We can see here that whatever A and B are, they are not mutually exclusive because they have overlap. So just whenever you're given a Venn diagram, that's the automatic assumption. Okay. So the 7, 3, and 11 represent how many outcomes there are. So maybe event A is like picking a ball numbered 1 to 7, right? Or maybe, I don't know what they are, but that 7 just means that there's 7 outcomes in that circle part. So how many outcomes are described? So if we go 7 plus 3 plus 11, and then here's the 4, right? Down the neither. So that's 10, 21, 25. So the universal is 25. So that's the total number of outcomes. That's the universal. So then the probability of A, so this represents, so this is A, so everything in circle A, So you're going to go 7 plus 3. So number of favorable over total number. So you get 10 over 25. So you could reduce that down to 2/5. You could write it as 0.4, or you could say 40%. So whatever this scenario is, that's the answer. So probability of B would be anything in circle B. So 3 plus 11 over the 25. So 14 over 25. And again, if you want to write that as a decimal or as a percent, I don't know this one off the top of my head. It is 56% or 0.56. Okay. Okay, so set theory now. So again, learning what these things represent. So this means union. This means intersect. So intersect is the overlap. Union is everything. So the overlap is 3 out of 25. A or B is 7 plus 3 plus 11 over 25. So or is everything. And, so again, this would say and. This one is or. So again, on the diploma, it might use the language A and B, or it might say intersection of A and B, or it might say A symbol B. They all mean the same thing. So you'll see me trying to get you guys to understand that intersect and this are all the same thing. They're all synonyms. Okay. What does that little dash after the A mean? Not A. Oh, hey, yeah, 1 sec, Alan. Okay, so everything outside circle A, so that would be outside that. So that would be 11 plus 4. So that's 15 out of 25. Okay. So in set theory, the question was, so in our 2 units ago, that was the set theory question. The number of elements outside of A. So the answer would just be 11 plus 4. When we use probability, probability just means put it over the total. It's just that one extra piece to the question. So on the diploma, remember you've only got 32 questions for the entire course. You have had unit ends with 32 questions. Okay, but they have 32 questions for the entire course. So in this chunk, they can ask probability questions that use all the set theory concepts. So they can double dip. Okay, so wherever they can do that, they will often do that because then they can cover more topics with a single question. Okay. Oop. Okay, so let's do a little problem solving. So it says there are 38 students in a grade 12 class. Of these grade 12 students, there are 19 in drama, 14 in band. 8 are in both. What's the probability that a randomly selected student in grade 12 is either the band or the drama club? Okay, so if you want to do it by Venn diagram, so we've got drama and band, and we've got the universals 38. Now, why do I know that there's overlap? Why do I know that this is the picture? What's part of the question that's telling me that there's overlap? Is the 8 students in both. Okay, so again, this is where we start. So you always start in the overlap and then you work your way out. Hey, you gonna do that? Okay, so 8 in the middle. So of the 19 do drama. So we know that the whole drama circle has to be 19 and the whole band circle needs to be 14. So that's why you start in the middle, because you want to subtract off. So this would be 11 and this would be 6. Yes, I can math. Okay. Then if we add up all these, so if you go 11 plus 8 plus 6, you get out 25. But there was 38 in my universal set, so that leaves 13 with neither. On the set theory test, this a lot of you forgot to do. So you always have to make sure that all those numbers add up to give you your universal before you even bother answering a question. Okay. So what's the probability? So because we're talking about probability, we know that the denominator has to be 38 because that's the total number. Okay. So now we actually read the question to see what the numerator has to be. They're in either band or drama. So band or drama, we're just going to take everything in here and add it to everything in here. So we're just going to go 11 plus 8 plus 6. So that is 25 out of 38. If you want to convert it to a decimal, if you want to convert it to a percent, you do you. Okay? Okay. If you want to use the formula, see how the question says or? So we want to do probability of band or drama. So the formula is the same regardless. So we're going to go probability of band plus the probability of drama. Then we have to decide, does this scenario have overlap? And yes, it does. So we're going to minus off the overlap. Okay? So how many kids are in band? 14 in band out of a total of 38 kids. How many in drama? 19 out of 38. How many are in both? So the overlap is the both. That is 8 out of 38. So if you punch into your calculator 14 plus 19 minus 8, you should get out, if I have done it right, 25. So it is entirely up to you which question makes sense, like how you go about attacking this. There are some of you that are super physicsy and you love those formulas. There's others of you that are totally visual and you'd much prefer the set theory way, the Venn diagram. You do you. Can you know both ways and then use them to compare? Absolutely. Will the diploma make you do it in one way over another? No. It's not 30-1. They cannot force the process. They just want you to know the process. Okay. Are you good with that? Okay. Okay. A school newspaper published the results of a recent survey. Eating habits. 62% skip breakfast. Shame on them. 24% skip lunch. I hope it's not the same group of kids because that's insanity. And 11 out of the 50 students eat both. Yay for them. Okay. So what's the probability that randomly skips both breakfast and lunch? What's the probability that they skip at least one? And to the nearest hundredth, what's the probability that a randomly chosen student skips only breakfast but not lunch? Okay, I'm going to pause it and let's see what you can do with this information. Okay. Okay, so honestly, when I see both, okay, that's usually my indication to go ahead and do Venn diagrams. The other thing is, excuse me, this right here, when it says they only skip breakfast but not lunch, that's that like moon shape, right? Where they have only part of a circle. This type of question is difficult to do using the formulas, like this one right here, because the formula is just probability of A plus probability of B minus overlap. It's difficult to manipulate the formula to do it for that type of question. But Venn diagrams, it works lickety split. Okay, so Venn diagram. We've got skipping breakfast, skipping lunch. And because it's given to you in percents, what do we know the universal is? The universal is an automatic 100. right? Oh, 50 students. Oh, I see. So that's what they did. So you could, okay, so option number 1, option number 2, because I'm all about options. We'll do it both ways, and I'll show you that it doesn't matter. Okay? Yeah. So 62% skip breakfast. That means this circle has to be 62. 24 skip lunch. Okay? 11 out of the 50 eat both. Eat both. So these two numbers represent skipping, not eating. So if 11 out of 50 eat, that means then that 39 out of 50 skip. Right? You have to know what you're comparing. You can't compare apples and kiwis, right? It has to be apples and apples. So if you're doing percents, 39 out of 50 is 78%. Oh, that doesn't work. What the what? It's still not going to work. Because if you do eating, okay, so we need to make sure that you're comparing apples to apples. So you either want to do the diagram for everybody eating breakfast. So it would be 62 minus 100, 24 minus 100. So 38%, 76%. And then 11 out of 50 eat both, so that would be 22%. So the eating one worked. So 38 minus 22 is 16. 76 minus 22 is 54. Now, what I don't understand is why the skipping picture doesn't work. Because the skipping picture would be 78% skip, but then you're going to have a negative number here, and that doesn't work. So I'm not quite sure why we have to do it from an eating standpoint and not a skipping standpoint. I know for a fact that on the diploma, it has to work both ways. Like if you read it from the eating standpoint, you could set it up. If you set it up from the skipping standpoint, it would still work. I don't know why this one's not. There's something wrong with my numbers, essentially. Okay. So let me draw it better down here. So if they eat, okay, so if they eat breakfast, that would be 38% eat breakfast and 76% eat lunch and 22% eat both breakfast and lunch. Okay, I don't know why doing it by skipping is not working. If you want to do it with numbers, so this is universal being 100, this would be 11 out of 50. 38% of 50 is, what's 38% of 50? 0.38, I think 19. And 76% of 50 is 38. Okay. So we would just subtract here for percents. So that would be 16. Subtract here 44. Subtract here would be 8. And subtract here 27. So again, each of these numbers represent a percent. Each of these numbers represent a number. So 11 people eat both. Okay. Whereas this one, 22% eat both. So it's the same picture. It's just if you're doing it by number, if you're doing it by percent. Okay. But the point of this is all your numbers have to have the same units. So in this case, they're all having to do with eating. Okay. I don't know why it's not working for skipping. I don't know. I don't know what I did wrong there. I'm sure it'll occur to me at 3 in the morning while I'm thinking about this, but not right now. Okay, let's get to the stuff. What's the probability that they skip both breakfast and lunch? Oh, they skip. Oh, yes, sorry, I forgot to do the neither. So what's 16 plus... So 16 plus 22 plus 44 is 82. So that would be 18% here. Oh, it's 54. Sorry. So then this is 8, right? So 8% would be 4 people out of 50. Okay. Okay, you know what? I'm starting to hate this question. And the reason why I hate this question is because every one of these says skip. Yeah, let's do that. Okay, let's just make it eat. Let's just change the question. So what's the probability? Wouldn't it be nice if the diploma was like that? You know what? I don't want I don't want to do not. I just want to do the positive. Let's just make it that. Okay, so what's the probability that a randomly selected student eats breakfast and lunch? That would be 22% or 11 out of 50. I guess that was already here. Okay. What's the probability that a randomly chosen student eats at least one of breakfast or lunch? So again, breakfast or lunch. So you would go 16 plus 22 plus 54 out of 100. Or you would do 8 plus 11 plus 27 out of 50. Either way, you get out the same answer. To the nearest hundredth, what's the probability that a randomly chosen student from this group only eats breakfast but not lunch? And this is where the Venn diagram is hugely helpful. Eats only a breakfast and not lunch. That's that number right there. Right? So you can't be in the lunch circle, you can only be there. So that would be either 16 out of 100 or you could do 8 out of 50. Okay. So again, I apologize for that one being confusing, but the point I do want to make, if my math had been better, was make sure that all of your numbers are communicating the same thing, like eat, 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 or skip, skip, skip. Okay. Can I go on? Okay. So these next couple questions are questions off of old diplomas. So again, I'm going to go quiet. So there's how many questions here? There are there's 2 questions. So I'm going to hit pause. I'm going to give you about 5 minutes to try both of these, and then we'll go through them together. Okay. Okay, let's see how you do. So keep in mind, if you take 4 minutes per question on the diploma, that's a 2-hour exam. That's taking 4 minutes per question. So in other words, if I had just given you 8 minutes, I ended up giving you like 3.5. So if you time it out to 3.5 minutes for 2 questions, you're getting done in an hour. You have 6. Okay, so right, so just right, you just do what you need to do. So not every question. Look, the rationals are going to take you longer because the rationals are multi-step questions, right? So the multiple choice numeric response on the rationals, you're doing like 6 or 7 steps, but you're getting 1 mark. These are designed to be done in kind of one-step fashion. Okay, so let's just take the break since the bell just rang. When you come back, I'll go through these 2 answers and then we'll give you some work time. Okay. Okay, so I did not write these questions. These are off of old diplomas. So expect similar wording. Okay. So the key with the first one here is that every minute you want to convert that to 60 seconds. So you're always comparing like with like. Okay. So are these mutually exclusive or not mutually exclusive? In other words, does this have any overlap? No, there's no overlap. It's impossible for the light to be red and yellow at the same time. So when it says red or yellow, all I do is just use the formula. Or means add, So I just do that. I don't even bother with a Venn diagram because there's no overlap. Okay? So red, it's red for 30 seconds out of 60. It's yellow for 5 seconds out of 60. So 35 out of 60, and you reduce that down. No, this is just multiple choice. I'm just showing you how I do it. Yep. Nope. So which one is it? 7 out of 12. Okay. No, in multiple choice, you get, the frustrating thing with multiple choice is you get 1 mark, regardless if it's no steps or 6 steps. It's 1 mark. So on the rational section, you just got to slow down and go, okay, this is the sucky part of the diploma. I'm going to have to do 12 things to get my 1 mark. And then once you get to set theory questions, you're like, okay, 1 mark and you're done. There's 4 rational questions. There's 4 gaming questions. Games, like fill in the Sudoku. They're worth the same number of marks, but it's not the same level of math. And so you just have to take each unit for what it is. Okay? So think of the diploma as a slow burn, right? You start off with a little bit of gaming, you do set theory, you do probability, you do perms and comms. And then it's like wham, rationals. Right? And then you do exponents and logs, and then you finish up with our last unit. So it goes easy, build, and then easy, and then the long answer at the end. And the 2 long answer questions at the end are going to pull from multiple units. So part A might be a set theory question, part B might be a rationals question, but they all have the same theme. Hello. You guys kept looking. Who was it? Nobody? Oh, okay. Well, did she try to come in? Okay. Okay. All right. Okay. So on those, oops, there we go. Okay, so on the diploma, so those last 2 long answer questions, they're going to have a theme. So on like January's exam, one of the themes was a winter carnival. So one of the questions was, it was exponential, somebody had hot chocolate. So the temperature started here and its temperature was decaying, like exponential decay. And you have to find the equation of the curve. So they gave you, it says temperature of hot chocolate over time. They gave you all the points. You have to figure out the equation, a times b to the power of x, right? The next question was set theory. It said, okay, like, what's the chance of you being able to get on this ride? If you have to wait this many minutes on this ride, this many minutes on this ride, what's the chance of you being able to get on this ride and this ride, which is what our next concept is, right? So all the questions had to do with the winter carnival. There was 3 or 4 parts, but they all came from different units. Okay, so the last 2 pages of the diploma is like a brain barf. Like it's just like a, okay, here's everything that we've covered in the course on little tidbits. But the long answer, you get credit for your work. So even if you can't make it all the way through, you're going to get partial marks. Okay. Okay. Malaga, Spain lies in a region of Europe known as Costa del Sol. The probability of sunshine on any given day is 0.89. Okay, so the chances of, so in other words, number of favorable over total number is 89 out of 100. So however you want to think of it. In a non-leap year of 365 days, the average number of days of the year that a tourist could expect to experience weather other than sunshine. So if the chance of sunshine is 89%, not sunshine would be the other 11%. Now, it doesn't mean on that not sunshine day, whether it's going to be cloudy or rainy or stormy, we don't know. We just know it's not sunshine. Okay? So they have literally broken into sunshine and not sunshine. That's it. So 11% of your days are going to be not sunshine. So all this is saying is find me 11% of 365. Or in other words, on your calculator, 0.11 times 365. That's it. So you get 40.15. Now, to the nearest whole number, what's 40.15 to the nearest whole number? 40 days. So on your numeric response sheet, you would color in 40, just like that. Okay, so you'd start. Okay. Okay, so I gave you a worksheet at the beginning of class. So what you can do, your